guys, welcome back to the channel. I'm Satan Juan, currently the student of BTech CSE with the specialization of AI and data engineering. So today I am here with the all new topic, that is the model banking system using the star schema. So now let's just discuss about it. So hey guys, welcome back. Today I'm here with you all with the all new project that is on the model banking system using the star schema. So basically, a model banking system is a conceptual or simplified representation of the core functions and processes of a real-world banking system. It is typically used for educational research, development, or simulation purposes to help understand how different components of banking system work together. A model banking system focuses on key elements such as customer accounts, transactions, loans, deposits, withdrawals, and other banking activities. So basically, a model banking system uses a star schema. That is a type of data warehouse design used for analytics and reporting in the banking sector. The star schema organizes data into fact and dimensions tables, allowing for efficient query performance and easy data analysis. It is often used to model transactional and historical data and while providing insights into the customer behavior, loan performance, account transaction, etc. So now let's talk about the components of star schema. Components of a star schema for a banking system are fact table. Fact table is the central table in the star schema that contains the key performance indicators or measures of the system. In the banking system, this could represent various financial metrics like transaction amounts, loan balances, or interest earned. Fact tables often have foreign keys linking them to dimension tables. So example fields are transaction ID, account ID, transaction amount, transaction date, loan amount. Wait, let me just write it for you. So examples of these fields are first is a transaction ID, then is account ID, transaction amount, mm, transaction date, then loan amount, then after loan amount, interest rate, fee charged. So these are basically the example of the different fields that are there in the banking sector. So now let's talk about the dimension tables. So basically dimension tables provides context for the data, the fact table. They contain descriptive attributes, that means the textual data, that explain the who, what, when, and where of the data. Dimension tables are denormalized, meaning they store data in flat structures for ease of querying. So common dimension tables in banking system are number one is the customer customer ID, then customer ID, then customer name, then its address, then customer age, and after customer age there is customer category, customer category. So there are basic things that are in the customer dimensions are, that is the customer ID, customer name, customer address, customer age, and customer category. So now let's talk about the account dimension. Account dimension basically stores in phone account dimension basically stores information about bank accounts, including account type, branch, and status. So account dimension includes account ID, account type, branch location, sorry, not the branch location, account status. Status. So these are the things that are basically included in the account dimension. So here we talked about all the three things. Uh, first of all, that is just the example of the fields that are there in the banking sector. That is transaction ID, account ID, transaction amount, transaction date, loan amount, interest rate, fee charged. Then we talked about the customer dimensions. Then customer dimensions include customer ID, customer name, customer address, customer age, customer category. And after that, we talked about the account dimensions, which include account ID, account type, account status. So moving on towards the branch dimension. So basically, the branch dimension includes branch ID, branch name, and its location. So basically, these are things that are included in the branch dimension. Basically, branch dimension provides the details about the branch where the transaction is going to occur or where the transaction is being done. So next is the time dimension. So time dimension basically includes the date, day, month, year, quarter, and etc. So these are things that are basically included in time dimension. Now moving on towards transaction type dimension. It describes the nature of the transaction, that example deposit, withdrawal, transfer, loan payment, etc. Transaction type ID, transaction type description. So loan dimensions show details about loans in the system, such as loan type, loan amount, and interest rate. So uh, it also includes loan ID, loan type, loan amount, interest, etc. So now let's discuss about the example of the star schema. So this is the example based on the star, sorry, not this. So this is the example which is based on the star schema. So in this, basically the fact table is at the center, connected to each dimension table in a simplified diagram, and it would just look like this. Here you can see the customer dimension, which is connected to the central area, that is the fact table, and it is further divided into three branches, that is the account dimension, branch dimension, time dimension, and loan dimension. So now let's talk about the key benefits of using a star schema in banking. So efficient querying. The star schema design simplifies queries, and just wait first, let me just write about the key benefits that are there. So number one is efficient querying, then data aggregation, and after data aggregation it is easy understanding. Then after easy understanding, it's historical data analysis. So basically, these are the key benefits of using a star schema in banking. So first of all, let's talk about the efficient querying. In efficient querying, the star schema design simplifies queries and speeds up reporting analytical queries like total deposits by branch or average loan balance by customer category that can be executed more efficiently. Second, about the data aggregation. Data aggregation measures like total transaction amounts or loan interest, which can be quickly aggregated across different dimensions like time, branch, or customer. Easy to understand. Easy understanding includes star schema are easy to understand and use by non-technical staff like business analysts because of the clear distinction between facts and dimensions, and also in the historical data analysis. Banking systems require keeping track of historical data for reporting and regulatory purposes. A star schema makes it easier to understand trends over time by using time dimension. So example use case here we will just take is that is the load performance analysis. So basically the loan performance analysis are objective is to analyze loan performance by branch, loan type and customer category over the past year. So query aggregate loan amounts, total interest collected and number of loans issued by branch, loan type and customer category. In schema design, it includes the fact table. It will store loan amounts, interest and loan issue, loan issuance dates. Dimension tables will include details about the branch, loan type, customer and time. This schema design supports complex queries while making the data structures intuitive and manageable for data analytics and banking professionals. So, so this was all about the model banking system. So basically, let me make you walk through this PPT that we have made. So in this PPT, we are just talking about the model banking system, which is using star schema that I have explained. And then here is the basic introduction to this. Then yeah, so here you can see that the banking system star schema that is to includes dimension, account, customer, transactions, branch, product. So account it includes account key, account number, account type, opening date. In customer it includes customer key, customer ID, customer name, customer email, customer phone number. In transactions it includes transaction ID, account key, customer name, date key, product, branch key, amount, transaction type. In branch it includes branch key, branch ID, branch name, branch location. In product this includes the product key, product ID, product name and product category. So in dimension, that is the date. It includes date key, full date, year, month, and data week. So that is a breakdown of the whole code. So here you can see that in transaction dimension, it will include all these things. And so basically, transaction as account, and transaction involves customer. Transaction occurs on date, and transaction happens at branch. And transaction reacts to the product that is being delivered. So these are the particular codes that we have just worked upon. So first we have just created the table of the dim date. We have added particular uh, columns into it. And it's similar with the product and branch. And this is the particular output for this. As you can see, transaction ID with the account key, customer key, date key, product key, branch key, amount, transaction type. So thank you very much for watching the video. I hope you liked it. Thank you.